What's up guys, it's Josh here from KeepItTechie, where I help you learn Linux one command at a time. And today I want to talk about something I personally find fascinating, and that's digital forensics. And more specifically, we're going to explore the Sleuth Kit, which is a collection of forensics tools you can run right inside your Linux box. And this suite lets you investigate images, recover deleted files, and peek under the hood of a file system without depending on the OS itself. And guess what? You don't have to be a government investigator or work in cybercrime to learn this stuff. It's all open source. It's all available on Linux, and it's something you can practice right now in your home lab. Now, before we get rolling, go ahead and hit that like button if videos like this help you sharpen your skills. And it also tells YouTube this video is worth sharing with folks who are getting into Linux and security. All right, let's jump into it. All right, so I'm at sleuthkit.org, and let's start with the basics. What exactly is Sleuth Kit? Well, Sleuth Kit, or TSK for short, is a collection of Unix-based forensic tools that let you analyze volumes and file system data. So think of it as a Swiss Army knife for looking inside of hard drives, SSDs, USB sticks, and even virtual machine images. Now, what makes it so powerful is that it doesn't rely on the operating system to interpret the file system. Instead, it directly reads the disk structure. So that means it can show you hidden files, deleted files, slack space, and so on. And it also supports a ton of file systems. So NTFS, FAT, exFAT, Ext4, 3, 2, basically the ones you'll run into in the real world. Now, a lot of people in law enforcement and cybersecurity use the Sleuth Kit, but I want to stress this to you guys. You don't have to be a detective or someone with a badge to use tools like this. You can install it today on your Linux box and use it to learn how file systems really work. And that's exactly what we're going to be doing in today's video. And before I move over to my virtual machine, I also want to show you guys another site. This is LinuxLEO. I want to give them a shout out. I've had this site bookmarked for a while, but they have some awesome images over here you can go through and run some of these commands against. I'll be using the Able3 Ext4 disk image, and I'll be downloading that in my virtual machine so I can have an example to demo for you guys. And also, LinuxLEO has a YouTube channel. Go down and subscribe to their YouTube channel. It's definitely a dope site that they have. They don't have any content on their YouTube page, but he's definitely keeping up with all the documentation on his site. Like, for instance, this beginner guide, I recommend you guys get that. He has the Law Enforcement and Forensics Examiner Introduction to Linux. And so you can download this PDF. As you can see, he's actively working on it. This was released September of 2025, so this month. So he's definitely maintaining the documentation. So support him by subscribing to his channel, or he may have a donation button down here as well. So you ready? Let's get to it. What's up, y'all? If you've been watching my channel for a minute, you already know I stay talking about Linux. And if you're looking for a solid, reliable enterprise Linux distro, let me put you on to Rocky Linux. This is the go-to replacement for CentOS, and it's built for the community, by the community. It's got everything you need for a stable and secure Linux experience, whether you're running servers, home labs, or enterprise workloads. And the best part, it's backed by CIQ, making sure it stays rock solid for the long haul. So if you're tired of these companies pulling a plug on your favorite distros, Rocky Linux is where you need to be. And I've covered Rocky Linux before, and trust me, it's worth checking out. So head over to rockylinux.org to learn more and get started. Keep it techie. Peace. All right, so I'm connected to my virtual machine. This is Parrot OS. And what you want to do first is get the Sleuth Kit tools installed. But on Parrot OS and Kali Linux, it is already included in those distros because, you know, those are security distros. They're marketed to security professionals. So if you look under pen testing and then under digital forensics, you'll see the Sleuth Kit included. And really, like I said, the Sleuth Kit is just a collection of tools. And these tools are essentially commands that you can run in your terminal. And so the man page is very important when it comes to this stuff. So let's just click on one. Let's go to istat. And this will give you just the information about the command, and it also shows you how to actually run it. Now, what it's doing right here is running as root. I don't want to run it as root. I want to just keep everything on my Josh account. But this breaks down all the options that you have for that command. So you can click on them here, or you can also just type the man command and then istat, and press enter. And that'll give you the information about it. See, as you can see, it says display details of metadata structure, meaning inodes. And then it gives you a synopsis and description, and then all the options and what they actually do. So just go down and quit there. If you ever need any help, just know that you can go to those man pages, or you can go here under digital forensics and then sleuth kit, and you can click on whichever one you want so you can get an understanding of what each one of those commands do. So now let's get into our demo. Let's close this terminal here, and we can go down and clear the screen. And what I want to do is set up a environment for us to work in. And you can look at this as we're working a case, like we're an investigator and we're working a case, and we need to look at things on a particular hard drive image. Because most of the time when they're doing investigations, they'll go down and image the hard drive and then use that to actually work on, to recover files and all that good stuff. So let's start by creating our workspace. So let's type make dir, that's for make a directory -p, and we can create a directory called forensics, and then -lab, and then we can create another folder called cases. So let's go down and press enter, and let's cd into those directories. Let's go into cases as well, and this is where we're going to drop our image file in. And so all you have to do is go back over to the website and find whichever image you want to download, right click on it, hit copy link address, and I switch back over to your system, and then type wget, and then paste our link in there so we can download our image file. And it will store it in the current working directory, which is our cases directory under forensic labs within our home directory. And boom, we are done. We have our image file. Now, when you're working a case like this, one thing you want to do is record a checksum. And this is mainly for chain of custody. Let me show you guys how to do that right fast. You can use built-in application called SHA-256 sum. And we want to get the sum for our archive that we just downloaded, Able3. And then let's go down and pipe this. That way we have a record of it as well. We can use the T command, and it's TEE. And then I'll just type able and tab it out. And what we want to do is let's add at the end of it, let's change the extension to SHA-256 and press enter. And this will create our checksum. And this is similar to what developers of Linux distros do when they put out a new ISO. They'll put out a checksum just so you guys can verify that you have the image that they put out there. Now let's go down and extract our archive right fast. So all you gotta do is type tor, and then there are some options, xzf, and then specify your archive. We'll tab it out, press, and that will extract our archive to that same location. So now that it's extracted, we can go into the directory right fast. So let's go into able_3, press enter, and then let's run a ls-lah, that's fine, and press enter. And that way we can see all of our files that are in there. Now let me show you guys how to get some image metadata, as well as do a recon on the partition. And this is where we'll start using some of the sleuth commands. So I was going to clear, but I want you guys to at least see the files that I'm gonna run this against. So we use the command image stats. And one thing I need to do, let me go down and start doing this a little more, but let's run a man page for image stat so you guys can see what it is. So display details of image file. Synopsis, there's your arguments down at the bottom, as well as options. And you scroll through and get more information about the actual command. But let's go down and run it right fast. So image stats, and we're going to run this against our able000. Let's run it against the first one, raw file, and this should look at everything. And I'll have examples of these full commands. You can stop there and run it just there. I'm gonna just use sed right fast to show the information in a little bit better light. But 1-80p, I believe that's what it is, and then press enter, and boom, there we go. So this is our metadata for our image file, and as you can see, it breaks out the sectors where they're located as far as the files that are on here. So you can see how it's broken up. You'll see that it starts the next sector in dash, then in .001 after 000, and so on. Now let me show you guys how to look at the partition table. It's another command, sleuth command. You can type, and then actually let's go man mmls so you can see what it does. It displays the partition layout of a volume system. And like I said, synopsis, description, arguments, all that good stuff is in there. You want to make sure you check that out if you need some help. So mmls, and then let's run it against our able3 3000, press enter, and boom, this breaks our partitions. And if we look into this a little bit more and just look at each one of the columns, so we got our slots, we got our start, end of our sectors, we got the length, and we got our description. And so as you can see right in here, we have a Linux file system. And just based on me understanding how this looks like either our roots, and then this one right here looks like our home directory. So that's a Linux file system as well. So let's say that's where we want to start looking. So with our other commands that we're going to run that I'll show you guys next, we need to know the start of the sector. And so that's why you want to make sure you select where you want to start so you can look at just that partition. And so this partition starts at 10.44.48. So make a mental note of that, or you can copy it. And what we can do is let's open up a notepad. So Pluma, there we go. And let's go down and paste that number in there. That is the start of the sector that we want to focus in on, which I believe is our home directory on here. And one thing within the Linux terminal, you can set variables, at least for this session that we're in, or TTY. So let's set a variable for this. So when we run our commands, we could call that variable 10.44.48. That'll get annoying to constantly remember that, especially once we start scrolling up, or it starts scrolling up and you can't see, you have to keep scrolling up and looking at the sector numbers and all that stuff. You can set a variable in. So let's, this will be our that we'll use for our sector. So let's go on and create a variable. We can just name it off. And then let's go equals, and let's drop in our sector number and go down and press enter, and that'll set that for us. And let's echo it out just to verify that it's there. So let's go echo, I think it's single quotes, and then in order to call a variable, you need to put the $sign in front of it. So $OFF and press enter. It did not call because I believe it is our double quotes. So sorry about that. Boom. And there we go. So that is our variable that we have set on the system. And now once you close this terminal, it's going to wipe that variable, just so you guys. Now what you want to do next is verify the file system at that offset. So we want to start at this offset and we want to verify what that file system is. We know it's a Linux file system, but what type? And so there's another command. Let's type man and then fsstat and press enter. And this will display general details of a file system. So that's what you want to use that for. Let's go down and run it. So fsstats, and then we want to use our offset. So that's the start of our file system, and we're trying to verify what it is. So we have to use -o, and then we can call our variables. So let's go $OFF, and then let's look at our Able3 and let's go down and press enter. And if we scroll back up here to the top, and I just wanted to break all this down for you guys so you guys can see, you can find out what the file system is. So as we can see, it's Ext4. We already knew that, but I just wanted to show you guys how to find it in case you needed to. This was last mounted at our home directory, so my guess was right. So that is our home directory, and I only know that based on the way the operating system typically sets up the hard drives when you're doing the install of a Linux OS. And then there's a lot of metadata information. You can check out the nodes, the amount of nodes, free nodes, the sizes, the range, the block sizes, the block groups, and as you can see, it breaks them all out for you. So this is the number of block groups, which is 13. So if you go down, that'll probably end at 12. So group 12. Yeah. So 13 groups. And so you can get a lot of information from this command. So now that we know what the file system is, which is Ext4, which we kind of knew beforehand, we just wanted to verify it. Let me show you guys how to enumerate files. And there's another command within the Sleuth Kit. Just type man and then FLS and press enter. This will give you the information of it. So it's list file and directory names in a disk image. So this is definitely a important command. Now let's go down and clear just to bring everything up to the top. And let's go down and run our FLS command. So we can specify our file system type, and that is Ext4. And then we can also pull in our variable under O, which is the start of our sector. And let's go and type in our variable. And then we have to type in our image and 000 0. And let's use sed to kind of clean it up a little bit. Let's go -n and then 140p and close out our single quote there and press enter. And there we go. And so this is a quick root view. And as you can see, it breaks everything out for you. So you got your lost and found, FTP, Albert, and you have some orphan files as well. Now, let's say you want to look at everything recursively. It'll break everything out for you so you guys can see all the files that are listed and the paths as well as the inode. So let's use that same command, the fls command, and let's remove this sed. We don't need that. And actually, I'll leave that pipe there because we can output our results to a file. So after our sector stored, let's just use another option, drop that in there. So -r for recursive and -p for the path. And this will break out everything. This will go down the folder tree and find all the files that are there. And then also let's use T to kind of track what we're looking at. This will save our search for us. So T and then ... That way we can do it outside of this folder. It'll go up one directory and then we can create a file called Able3. And let's just do _full.txt. And this will be the full tree. And let's go down and press enter and it will print it out to the screen as you can see, but it'll also write it out to that file that we specified. And there we go. There is a breakdown of all the files there. Now, let's say we only want to look at deleted entries because we want to gather something that maybe this person was hiding. You know what I'm saying? So let's look for deleted entries only. And we want to use recursive as well. So I'm going to type up arrow and then let's make another folder. Let's call it deleted. Another file, that'll be the deleted one that we'll use for this. And all we have to do is add another option in here. And let me know if you guessed it because it's -D for deleted. As you can see, they kind of kept all of these options to where they make sense. Some applications don't always do that, but this one, they actually kept it that way. So this will look at all the folders and files recursively, as well as the paths. And then it's going to look for deleted entries. So let's go down and press enter and it will output just the deleted files within that sector or a partition for that file system. And so that's pretty cool, right? These are files that have been deleted by the user that owns this hard drive. And it is kind of creepy when you think about it, but this is how they do investigations to catch people that are doing very illegal things and trying to hide it from law enforcement. Now, let me explain to you how to read these files. So let's scroll up. I want to look at this one specifically, and this is a index.html and it's an allocated regular file. And also the inode is 16. That is the number associated with this file. And the path kind of follows under Albert downloads. And so what we'll do is use the inode in the next command I want to show you guys, which is icat, to carve that file. But before we do that, let's inspect the inode for 16. So let me show you guys another command right fast. Let's go istat. Let's run the man page for that. So istat and press enter. And there we go. So it displays details of metadata structure for a inode. So let's go down and quit out of there just so you guys can get an understanding of what it is, and especially the stats for a inode. And let's use F for our file system. So Ext4, and then let's specify our sector. So -O, and then our variable, and then our image file. So Able3 000, and then we can specify our inode, which is 16. And then we can use sed again. Let's go up here and use sed -n 1,40p and press enter. There we go. So this will give you information about that inode. 16 is allocated. Allocated means that it actually has data. This is the mode for it. So read write, and that's associated with the permissions. We got it flags, the size, the last time it was accessed, and the last time it was modified, inode modified. So this was back in 2017, long time ago. And then the blocks. So that's where it's actually stored. So now let's show you the icat command, and I'll run the man page for that. So icat, press enter, and it outputs the content of a file based on its inode number. So what this will do is extract or copy the raw bytes referenced by a specific inode into a file. And what we'll do is just output it to a bin file, and then we'll figure out what type of file it is, which we really know what it is. I just want to take you guys through the process of trying to figure out what that file is once we get it off. And so let's run icat, and this will carve out that data. So let's go -F for our file system. So Ext4, and then -O, for our sector, at least the start of our sector. So we'll use our variable OFF and then the actual image file. So 000 and then our actual inode. And then what we want to do is write that copy to a location, a file location. And we can specify that by using an arrow. And then we could do dot just to go up a directory, and we can create a file called inode. Let's go _16 and then .bin and go down, press enter, and we are good. So it carved out that inode to our bin file. Now let me show you guys how to identify it. We can use a command that I showed you guys in my Linux Plus course that I have on my channel for free. And that command is file. And let me show you guys that right fast. So my man file determines file type. So this will help us determine what type of file it is. So let's hit Q to get out of there, and we can run file against our bin file, and this will allow us to figure out what to change it to in order for us to view it. So that inode.16.bin, if you run that against it, it will tell you what type of file it is. And as you can see, it's an HTML document, exit text. So we can actually change that to a HTML file. So we can go move /inode, and we can put it in that same location, and we can name it inode, but take the bin off and put HTML and press enter, and that will change that file to HTML file. And one thing you want to do, let's say this is investigation, you want to show your checksum for evidence. So you can run the SHA-256 command again, look at our sum or create a sum, then /inode, and we can pipe that into set-in and single quotes, and then what is that, 1,1 P. That should work for us. Press enter, and boom, there we go. So we got our checksum for that actual file, and that's important if later you need to prove what you did. All right, now this should be fun. Let's go down and open up our file. We can do it from the terminal using xdg-open. This will open up a editor. So let's go and then /inode and press enter, boom, and there we go. So it opens up our HTML file, and we extracted that from our image. Now let's try this against a deleted inode. Let's go down and clear. We're gonna basically do a lot of the same commands. First, let's look at our deleted files again. So you can go back up. We could just press up and find where we ran our deleted command. We can look at all the deleted files within that ext file system. Now looking at some of these file names, I'm not sure what they are. Like I said, I've had this site bookmarked, and I believe it was created by a investigator, but I still don't trust these files, so I'm not going to extract any of the deleted files. That's why I only focused in on that HTML file. But one thing you can do is run an istat on them, and this allows you to get information about the files without actually carving them out. Because let's say they're, I don't know, let's say this is suspicious. Some of this stuff looks, I don't know, looks like it could be, I don't know, I don't have a clue what this could be. So what I'm gonna do is run istat, and let's just record the output of the istat command. And we can, let's say, I don't know, let's say we're doing this like a real investigation, because like I said, I really don't know what this is, so I'm not gonna open it. That way nobody can fault me for looking at something I'm not supposed to. Looks, I don't know, it just don't look right. So let's go OFF, that is our sector start, and let's look at Able3 000, and then I don't know, let's look at 15. And what I'm doing is not looking at it, I'm fin to record the information behind it. And we can create, let's say a case notes. So let's use T-A, and then let's go // and let's create a text file called case notes, and then let's make it a text file. And like I said, this will only log the information. It'll create basically a record. So let's go and press enter. There we go. So that'll grab that information right there for us. It's allocated. There's some of the inode information. Last time it was accessed, 2017, all that good stuff. And based on my knowledge from looking at the site and going through the README and all that stuff, these file names are part of the training data set that this person put out there. And based on what he states on the website, he's a federal agent with one of these federal agencies. So it could be FBI, something to that effect. And some of these names, I guess they named them so they kind of look like stuff that it's not supposed to be, or you're not supposed to be looking at. But I'll document them and treat them like evidence. And that's one thing about it. As long as you don't extract the images or whatever this, you don't have to worry about anything, because the image file is there and we can show exactly what we did with the actual directory. Okay, so we're gonna cut this thing short. All right, so what we did today was we looked at the Sleuth Kit on Linux, and we learned how to set up a little practice lab with a sample disk image. We use tools like mml, fsstat, fls, and icat to explore partitions, view files, and even recover some content. We left most of it in place, but this is just scratching the surface. Sleuth Kit has a whole library of tools you can dive into. There's also a GUI version called Autopsy that sits on top of it if you prefer a more visual interface. And I'll probably do a video on that one a little bit later. But here's the main takeaway. Linux isn't just for running servers or desktops. It's also one of the best platforms for learning cybersecurity and digital forensics. And all the tools are free and open source. And again, shout out to LinuxLEO again. I believe these files are safe. I mean, based on all the information you put out there, as well as looked at it. I went through and looked at it so you guys can check it out, but he has his name everywhere on it. And I also made sure I looked up a LinkedIn for this person, and it is out there. And I also did a little bit of research on Barry J. Grundy, and he's been around for a while. So I believe all those files are safe. Just check it out. Like, this is an interview he did in E4 magazine. So he's a US Marine Corps veteran. So I'm pretty sure he's not putting out no illegal information or illegal documents, especially for people that are just trying to learn how to use this software. So that's it. If you enjoyed this, let me know down in the comments. Do you want me to keep going with more forensics tools, or maybe cover autopsy? I know I'm going to cover it in the future, but just let me know if you guys are interested in that. There are tools out there for memory analysis, which I was thinking about showing you guys as well. Now, don't forget to subscribe to KeepItTechie if you want to keep learning Linux in a simple, approachable way. And thanks for watching. And as always, keep learning, and I'll see you guys in the next one. KeepItTechie. Yo, what's up, y'all? Listen, if you've been sitting there thinking about making a move, let me tell you, tech is where it's at. I don't care where you coming from, whether you've got a degree, a GED, or just pure hustle. There's room for you in this game. You see, tech is more than just keyboards and code. It's solving problems, creating opportunities, and building the future. You already have what it takes, because tech doesn't care where you start. It cares where you're willing to go. You can teach yourself Linux, learn Python, break into cybersecurity, or even launch your own app. And the resources are out here for free. And yes, you heard me, free. Now, yeah, it's gonna take effort. You'll have to grind, but think about this. The time is gonna pass anyway. So why not invest it in a skill that'll change your life? I mean, tech doesn't just pay the bills, it opens doors to freedom, stability, and generational wealth. So stop doubting yourself, start small, stay consistent, and keep building. Because this isn't just a career, it's a movement. And guess what? You belong here. So let's get it, because the future is yours to build. KeepItTechie.
Wow.